So today we're going to be doing the determinant of an adjoint of a matrix, and these are quite specialised questions that you don't see very often at all, but they've got to be done, and they certainly appear in certain specialised maths exams. So basically there are two rules for an n by n matrix A that you just have to know, because you use a mixture of them all the time to answer these questions. The first one, the determinant of k, a scalar, times a matrix A is equal to the determinant of A times k to the power of n, where n is the n by n matrix, or that's another way of writing it. The second one is the determinant of the adjoint of A being a matrix, is equal to the determinant of A to the power of n minus 1. And the reason why that is, if we just look at here, the adjoint of A is defined as adjoint of A over determinant of A equals the inverse of A. So basically that means that the adjoint of A equals determinant of A times by A minus 1, the inverse matrix, and that is just a scalar, determinant of A. So basically the determinant of the adjoint of A equals the determinant of A times A minus 1, and by rule number 1, as this is just a scalar, the determinant of k times A is equal to the determinant of A, so that's the determinant of A minus 1, times by the scalar, which is the determinant of A to the power of n, which equals, and the determinant of an inverse matrix is 1 over the determinant of A, so times by A to the n equals the determinant of A to the n minus 1, which is where you get that from. Okay, that's just a little aside, just to make people understand. So what we're going to do, we're going to do 3 questions. The easiest way is just get stuck straight into them and learn as we go along. So here's question number 1. I'll pause the video if anyone wants to do it. Okay, so we have that A is a 3 by 3 matrix, and we have that the determinant of the adjoint of the adjoint of the adjoint of A, the matrix, is 12 to the power of 4. Then what is the determinant of the inverse of A times the adjoint of A? Okay, now I like to do these from inside out. So let's start with the adjoint of A. Well, let's let the determinant of A be equal to k, just to make it slightly easier. Okay, so the adjoint of A, therefore, is k squared. The determinant of the adjoint of A is k squared. So therefore, the determinant of the adjoint is k squared squared, and therefore the determinant of the adjoint of the adjoint of the adjoint is k squared squared squared. So that is k to the 8, and that we know equals 12 to the power of 4. Okay, so basically we know from that, well, that is root 12 to the power of 8, so therefore we know that k is equal to root 12, which is 2 root 3, which is the determinant of A. So now what we have to do is we have to find the determinant of A minus 1 times the adjoint of A. Well, the determinant of AB is equal to the determinant of A times the determinant of B. We've done that in a previous video. So therefore, the determinant of the inverse of A times the adjoint of A equals 1 over the determinant of A, which is 1 over 2 root 3. That's the inverse, times by the adjoint of A, which we know is equal to the determinant of A to the power of n minus 1, and we know that n is 3 here, so this is by rule 2, which equals 2 root 3, and so therefore our answer to number 1 is 2 root 3. Okay, now that's probably the easiest of the 3 that we're going to do, so let's move on to question 2, which is tougher. Here's question 2. I'll just pause the video if anybody wants to do it. Okay, so we're given that the determinant of A is 2, and we're given that it's an n by n matrix. Okay, so now what we need to do is we need to look at this thing and work out what n is. Okay, now I start from the inside. Okay, so the determinant of A minus 1, well, is equal to a half, because it's 1 over the determinant of A. So therefore, the determinant of 2A minus 1 by rule number 1 is equal to that, which is a scalar, 2 to the power of n times the determinant of A minus 1, which is 2, which is 2 to the n minus 1. Okay, so that's that bit done. Okay, now let's have a look at this bit here. The adjoint of that is going to be that to the power of n minus 1. That is by rule 2. And then when we look at 2 times the adjoint, by rule 1, that bit down there is going to be equal, so let's just put this here, 2 to the n minus 1 to the n minus 1, that's what we got here. But we now need to multiply by 2, so that is going to be the whole lot here, times by 2 to the n, that's by rule number 1, because it's just 2 times that matrix there. And then when we take the adjoint of that lot here, we have to multiply all of that, this is the adjoint here, we have to multiply all of that to the power of n minus 1. So the determinant of the adjoint of 2, the adjoint to a minus 1 is equal to this thing here. And let's just rewrite it, just make it a little bit simpler. 2 to the n minus 1 to the n minus 1 times 2 to the n, all to the power of n minus 1. Okay, so that basically equals 2 to the power of n minus 1 squared times by 2 to the n, all to the power of n minus 1, which equals 2 to the n minus 1 cubed times 2 to the n minus 1. Okay, now by the way, we know that that equals 2 to the power of 84. So what we're going to do in a minute, let's just keep simplifying this. So we know therefore that 2, let's just take n minus 1 out here, n minus 1 squared, add n, so 2 to the power of, that's just from here, equals 2 to the power of 84 from the question, and therefore we know that n minus 1 times n minus 1 squared add n must equal 84, just comparing the powers. And by inspection, and you will always be able to do this by inspection, n is 5. It's got to be an integer, and it's going to be a relatively low integer, so just try 1, 2, 3, 4 and 5, but when we get 5, that'll be 4 times by 4 squared add 5, which indeed equals 84. So the answer here is n equals 5, and that's the answer to the second one. Okay, here's the third one, so I'll pause the video if anybody wants to do it. Okay, so we know that A is a 3 by 3 matrix, and we're given that the determinant of A is 2. Then we have to work out what the determinant of 3, the adjoint of the determinant of 3A times A squared is. Okay, now the first thing to note is that the determinant of 3A, the determinant of anything is a scalar. Okay, so basically this is a scalar times A squared. But let's start from the inside anyway. Okay, so we need that the determinant of A squared, well, is the determinant of A times the determinant of A, which we know is 4, okay, because we know the determinant of A is 2, so that's so far so easy. And what we have to do now is find out the determinant of 3A. Well, the determinant of 3A is equal to 2 times 3 cubed. That is rule number 1. And we know that therefore the determinant of 3A times A squared, the determinant of 3A times A squared is equal to this, 2 times 3 cubed, because by rule number 1 it's a 3 by 3 matrix and we are multiplying by a scalar, times 4. And therefore the determinant of the adjoint of that thing there is equal to 2 times 3 cubed times 4 squared by rule number 2. And therefore 3 times the adjoint, again by rule number 1, what we're going to have to do is we're going to have to multiply this here by 3 cubed by rule number 1, because we're just multiplying this matrix here by 3, and so therefore the determinant gets multiplied by 3 cubed. So therefore we have, and that one's by rule number 1, so therefore we have our answer is equal to 2 times 3 cubed times 4, which is 2 squared times 3 cubed. Okay, and let's just simplify all of that. That equals 2 cubed times 3 to the 9 times 2 squared. We do have to be careful with all of this, times 3 cubed, which equals 2 to the 6 times 3 to the 18 times 2 to the 4 times 3 to the 3, which equals 2 to the 10 times 3 to the 21, and in actual fact it wants us to put it in the form 3 to the something, 6 to the something. So obviously let's put that as 2 to the 10, 3 to the 10, 3 to the 11, and 2 to the 10 times 3 to the 10 is 6 to the 10 times 3 to the 11. So therefore the determinant of the whole lot is 6 to the 10 times 3 to the 11, which is answer number 4. Okay, now I hope you found these useful. They're basically just practice, and all you have to really do is remember these two rules here, rule number 1 and rule number 2 here. They will always be a combination of the two, and I definitely prefer working from inside out, even though most teachers actually teach you to work from the outside in. I hope you found this useful. If you have, please like the video and subscribe to the Gresti Academy YouTube channel. Thank you.